All right, 3.9 day 2, and I got it ready for you guys this time, so hopefully it moves a little bit quicker. The last one was like 19 minutes. I'm like, oh, I wanted that to be like 10 minutes. Maybe I talked too much. Anyways, all right, so we're gonna try to go. All right, y equals 8 to the x, so we need to find dy dx, so that's the same as taking a derivative, right? So the derivative of y is 1, but it's a y, so dy dx, which is the same as y prime. Okay, and when we have 8 to the x, where's my little cheat sheet? Oh man, I didn't have it ready to go. We're using this a to the x rule right here. So it'll be natural log of a, which is the base, times whatever that was, a to the x. Okay, so this is going to be the natural log of 8 times 8 to the x. Well, it looks better when we throw that in front. So dy dx equals 8 to the x natural log of 8. There it is. Good, that's a little bit brighter now. All right, number 21, y equals log base 4 of x squared. Okay, we've got a log, so we're going to be using this one. The derivative of a log base a of x is going to equal 1 over natural log of a, which is the base, times x. Okay, so that means that I'm going to have, up here. I'll just use y prime. It's just easier to write. Equals, okay, well, we have to do the chain rule because we have stuff on the inside and it's going to be bigger than a 1. The derivative of x squared is a 2x times, that's going to turn into 1 over the natural log of the base is a 4, times the input value, which is that x squared. Okay. All right, we can clean some things up here, such as these x's, and that's it for now. So if I multiply across, it'll be 2 over, we'll put the x out front, x natural log of 4. And originally I had stopped there, but there is one more step that we can do because 4 has a 2 in it. Yes, that 4 is inside the natural log, and you might think that you're done, but we can use a property of exponents to bring out a 2 and reduce it even further. Because, I don't know if you guys remember this, you should remember it. You're going to be like, oh, when you see it. So whenever you can have an exponent, you always drop it in front of the log. So then this would be y prime equals 2 over 2 times x would be a 2x natural log of 2. And then those 2's will cancel, and our final answer would be 1 over x natural log of 2. So if you made it this far, where I am in the green, you're almost there. You have literally one more step left to follow, and then you'll be simplified all the way. All right, number 23, y equals log base 2 of 1 over x. It's helpful. We're going to have to take a derivative of that, so it's helpful when we undrop it like it's hot. So that's the same as x to the negative 1 power, because we are going to need to take the derivative of that to find dy dx. So the derivative of x to the negative first would be a negative 1x, and then we have to subtract 1, so that would be negative 2. And then the log turns into 1 over the natural log of the base is 2, times the input, which I'm just going to write it as x to the negative 1, because I don't want a fraction under a fraction. No need to make it look worse than it is, because that might throw us through a loop, and we don't want to do that. All right, so what I'm going to do next is I'm going to drop this like it's hot and throw this up. Ooh, I like that combo with the purple and the blue. It looks really pretty. All right, y prime equals, well, I have negative 1 times 1 is a negative 1, and that x is going to come up, so it'll be x to the positive 1. That x to the negative 2 is going to come down and become x squared, natural log of 2. And then those x's get to cancel. So this one cancels with one of them down here. So we'll have y prime equals negative 1 over x natural log of 2. And, oh, you know what? I should have mentioned this back here. We have an x in the denominator, so we have to state that x has to be greater than 0. And same down here, we got pretty much the same answer except negative. So x is in the denominator, so x has to be greater than 0 because we cannot have a negative in the denominator. Or, sorry, we cannot have a 0 in the denominator. What am I saying? I know that that's not, why would I say that? I don't even know. I must be tired. I am. And I did have a lot of coffee, so I am running on borrowed energy, and I'm probably going to crash and burn soon, so I just need to make it through before I crash. All right, so y equals natural log of 2 times log base 2 of x. Initially, I see two quantities multiplied, so initially I was thinking product rule, and we totally can do it with product rule. But natural log of 2, this right here, is a constant. It's just going to be a number, a real number. It'll be a decimal. Like, I can totally input natural log of 2, ln of 2, and I get a number. It's just a constant. So when I take the derivative of this is just going to sit out front. Okay, so y prime or dy dx equals log base 2 of x. Well, let's keep the natural log of 2 out front before we lose it. Times, we have to take the derivative of the inside, but the derivative of x is just a 1, so I don't need to write that. And the derivative overall, the log, is 1 over the natural log of the base times the input, which is just x. Okay, so guess what? These natural logs are going to cancel. So all I have left is 1 over x. How about them apples? Isn't that nice? That's just so pretty. I love it when a problem that looks so complicated just simplifies down to something just so bare minimum. It's just so cool, I think. I am a nerd though, so I find joy in those types of things. I hope you do too. All right, so number 51, I didn't write down the whole problem, but it's about the spread of a rumor. It says the spread of a rumor in a certain school is modeled by the equation, this one right here, where P of T is the total number of students who have heard the rumor T days after the rumor first started to spread. I hate rumors. Anyway, letter A says estimate the initial number of students who first heard the rumor. So that means we are looking for P of 0. Okay, so we need to plug in a 0 for t, so we'll have 300 over 1 plus 2 to the 4 minus 0 power. So that's 300 over, let's see, 2 to the 4th is 16. 16 plus 1 is 17. 300 divided by 17. I know it doesn't divide evenly. Oh, come on. 17.647. But this is the number of students, so you can't have 0.647 of a student, so you always round up to the nearest whole number. So that is 18 students then. So 18 students have initially heard the rumor. Okay. Next is how fast is the rumor spreading. So this is just like the example in the notes, like literally just like it, okay? And after 4 days. So because we're talking about how fast something is spreading, we're talking about velocity, which means we're talking about rate of change, which means we're talking about slope, which means we're talking about taking the derivative of P of T, okay? So because we have a fraction, that means we're going to be using quotient rule. Lipstick taser. Thank you, Mission, for telling me, because I was like, what was I thinking of? But you got me. You got what I was thinking. Oh my gosh. That made my day, by the way. All right, so first of all, it goes low d high, so low. Derivative of the high, derivative of 300 is 0. Minus high, d low, the derivative of the low. Well, the derivative of 1 is 0 plus the derivative of 2 to the 4 minus t power. Well, that would be, well, where's my cheat sheet? It would be the a to the x thing. So natural log of a times a to the x. So this would be the natural log of 2, because that's the base, times 2 to the 4 minus t. Okay. All over low squared. Well, the low is just 1 plus 2 to the 4 minus t power quantity squared. Okay, so I know that looks crazy. It's got a lot of things going on, but it's okay. That's 0. Okay, so let's clean this up. We'll have p prime of t equals negative 300. I always forget this. Like, I forgot when I was taking the derivative right here, you have to take the derivative of the exponent. And the derivative of 4 is 0. The derivative of negative t is a negative 1. So there's also a negative 1 out front there. Okay, so that negative times negative makes this a positive. I always forget that. And that's always a mistake I keep making. I need to stop doing that. Like, knock that crap off, Mrs. Garcia. All right, so times the, we'll put the 2 to the 4 minus t in front because it's kind of like a constant. And then natural log of 2, okay? All over the low squared. 1 plus 2 to the 4 minus t quantity squared. Okay. That is as simplified as we can make it. But remember, we're trying to find how fast the rumor is spreading after 4 days. So now let's find p prime of 4. So we're going to have 300 times 2 to the 4 minus 4, power, natural log of 2, all over 1 plus 2 to the 4 minus 4 power squared. Well, why am I going all crazy about the 4 minus 4? Well, 4 minus 4 is 0, and anything raised to the 0 power is 1. So that means I have 2 to the 0 is 1. So this is just 300 times the natural log of 2. This becomes 1. 1 plus 1 is 2. 2 squared is 4. So I literally just have to type that into my calculator and then I'm done. My husband opened the window, and so now it's nice and breezy outside and the air is really cool and it feels good, but it's blowing my papers around. And that's a little bit annoying. 300 times natural log of 2, I'm going to hit that first and then divide by 4. And I get this number. So if I round that to the nearest whole number, that would be 52. So that means that the rate, how fast the rumor is spreading, is 52 students per day. So that means it won't take long before the whole student body has heard the rumor. But isn't that the truth? Isn't that how it works? Now, I wonder if it's still that bad, because we're not really in person. But with social media, though, social media can be even worse than in person. So I don't know. Maybe it is worse. I don't know. Rumors suck. I remember being in rumors a lot. It just happens. Kids are mean. Hopefully you're not one of those. I don't believe that anyone in any of my classes would be, because I feel like I could trust all my students. Letter C, when will the rumor spread at its maximum rate? What is that rate? So when we try to find the maximum, that means on the graph, we're looking for where it peaks. So we want the slope to be 0. We want the tangent line to be a slope of 0 at that point. But since we're talking about how fast its rate is, that means we're talking about the derivative graph. So that means we're taking a double derivative to find where that maximum is. And this is where we want p prime, the derivative, to have a slope of 0. Okay? So one of the things we need to look at is like a number line and see what's going on, like positives and negatives. We want it to change from negative to positive or positive to negative to show that change. Well, if we want a peak, right? That means we need the slope to be positive on the left and negative on the right. That will mean it went up and then it turned around and went back down. So we need it to be plus and then minus. Well, where is that point? Where is that turning point? Okay, so we need to try a couple of different things. So this is where I showed you guys in the notes the other day. We need to set up our y equals. Okay, so I need to put the original function in there. That is 300 divided by, and we have to use parentheses, 1 plus 2 raised to the 4 minus x power instead of t, because they don't have t's here. Okay, so there is the original. And then for y2, this will be our first derivative. So I need to hit math 8. It's d dx. And then I want to input y1 as the function in there. So you hit alpha trace. You hit 1 to input y1. And then it's at any x value. Okay. And I think that's all we need for right now. Okay. So what I want to do is I want to go to the regular screen and I want to take the second derivative of this derivative. So this y2 is my first derivative. I want to take a third or a second derivative. Okay. So I want to exit the screen. Oh my gosh, the wind just closed my door. That scared me. Math 8 d dx of, and I want to input alpha trace y2 this time. And I want to try some values. First of all, let's try 4, because last time in the notes that ended up being the point where it was the maximum. So let's try it and see what we get. So this is the second derivative where x equals 4. And look at what I got. I got 0. So that means that the slope is 0 at 4. So that means it's going to be where the tangent is a horizontal line, a flat line. Okay, so let's test some numbers before the 4 and after the 4. So let's try setting x equal to 0 and see what happens. So to write down what we're doing, we did d dx of p double prime of t at, actually it was just p prime of t. This will give us the second derivative at x equals 4, and we got 0. Okay. Now let's try d dx of p prime of t, so taking the derivative of the derivative function, so the second derivative. But now let's try x equals 0. That's a number smaller than 4, so let's see what's happening to the left of 4. So same thing. Will it let me scroll back up? Nope, it won't let me do it. I have to do the whole thing over again. I always do that. Okay, math 8 d dx of alpha trace y2, and let's set it equal to 0 and see what I get. 7.04, that is a positive number. So we're positive on the left of 4, just to double check. And then let's test one to the right of 4. So let's do the same thing. But let's try like a 5. So math 8, d dx, alpha trace, 2 to plug in the derivative function so we can take the second derivative at x equals 5. And look what I get, a negative number, negative 10.67 or 68. All right, so it is doing our little peak thing. So that means that at a time of 4 days, that is when the rumor spreads at its maximum rate, which makes sense after a rumor starts. It's not long after it starts where it starts reaching its peak, okay? And then it's going to start slowing down because people get over it after a while. All right, so we have the max is at 4 days. And what is that rate? Well, we already know that at 4 days, the rate is 52 students per day. So 52, sorry, I'm out of room, students per day. And that's the answer. Okay, so we need to find the rate of change in order to find its maximum, because then at its maximum, that should be a horizontal line, and that's why we have to do a second derivative there. All right, I hope that explains it. There you go.